Yeah, g'day YouTubers, Spannerman again here with another video, a run up from yesterday's preparation of digital attack angle that we did the previous day. So we spent time preparing a chain using a progressive depth gauge on a 3/8 chain on the soft setting. So we filed that and got it all right. Then we put this gauge on and we spent a bit of time, as you would have seen in the video, done about half the chain. Took about 10 minutes, so in total it was about 20 minutes to do the whole chain. And long as it was over 6 and it wasn't over 7, so, 6.4, 6.5, just sort of around that sort of area, but long as it was over 6. Apparently around between 6 and 7 is a good attack angle. So first of all, you have to understand about angles. And if we talk about the standard type of gauge that people use, the constant depth gauge, which only takes 0.65 of a millimeter. So what's very interesting, and I sort of did a bit of a drawing, was that on this drawing here, that if we removed 1.5 millimeters from the tooth, meaning that as we file a tooth or grind it, by the time it gets down to the witness mark, you probably lost up to between 1.4 and 1.5 millimeters. Now on the other side, it's not the same. It's about 0.9 of a millimeter. But if you add the 0.65, it's already there. That'll come to about 1.55 millimeters. So why is that sort of like that? Why is that sort of so? Well, you have to understand, it's like the seesaw motion when we talk about angles. It's not an even angle. The raker acts as the middle of the seesaw, but the right side, the progressive depth gauge, sits on the tie bar, and that distance is about 14 millimeters. We've got a bit of a mock-up of that just here, so if we can sort of zoom in, hopefully you can see it. So if we look at the seesaw, and that's the way it was described to me, that if we look at this depth gauge here and we look where the progressive depth gauge touches on the tie bar, that distance is approximately 14 millimeters. This distance from here, this is on a brand new tooth, is approximately around about 6 to 7 millimeters. It depends on the manufacturer. So as we file the tooth here and we file down the depth gauge, it's not proportional because the distances is different. The only time that the distances get close is when we come to the end of the life, which is on the mark here, which is approximately 14 millimeters also. So in that case there, the seesaw motion comes right in effect and it's balanced. But at the moment, it's not balanced. You can change the amount that it does take off by making a different depth gauge, and it depends on how far from the raker that you let this sit on the tie bar. And that's why there's a soft and hard setting. And as you can see, the little window's in a different position. Now, I actually made about 5 of these gauges myself, and we've got them there. And these ones here roughly take off about 0.7 in the beginning. Now, what's interesting enough is when we grind or file the tooth down, and as I said before, by the time you get to the end of the life, you would have lost the height of the tooth would have decreased by about 1.4 millimeters. But using the progressive depth gauge, you've already got 0.65 of a millimeter. You'll only decrease about 0.95. So you'll get a total of about 1.5 millimeters. So it's not proportional. And that's okay. That's the way it was designed and made. So as we have a depth gauge like this, when we sit this on top of the teeth, if we grind a millimetre off the height of the tooth, we will grind a millimetre off the top of the raker. So that will definitely happen, but we'll still only have 0.65 of a millimetre because that's all this gauge will ever do. So, just to explain that again for the people that sort of may be a little bit confused. If this is the tooth and this witness mark on top is roughly at that point there, if we grind down from the start to the finish and the depth is 1.4 millimetres, we'll need to go down 1.4 millimetres on this because this gauge is designed to sit horizontal and it just lowers down. So it doesn't have any angles in it. It's just designed to lower down. So, but it will always have a gap of 0.65 of a millimetre. That's just the way it's designed. So if you understand that and you understand how the progressive depth gauge works, that you'll have a better understanding of what the attack angle does. So in the experiment that we did, we used the progressive depth gauge and we roughly had an attack angle. The attack angle could vary anywhere from around 4.4 up to about 5 and a bit. So there is a little bit of variation in there, but remember you're only talking about a 1.5 degrees. So you're not talking much. And the only thing that this does is take all the humps and bumps out, if you will. So it tries to, what it does do is make it much more accurate. So the distance, the gap is, everything's more uniform. The angle is much more accurate. You'll have an attack angle. The more time you spend, the more accurate your attack angle means. So, okay. In conclusion, after yesterday, we spent at least 3 hours, then we had a break, then I spent another 2 hours. So in total, I had a total of about 5 hours cutting out of this out of the chain that we did yesterday. So what's the conclusion? Well, if the attack angle and the depth gauges are set correctly, the chain won't have to, or the tooth won't have to work as hard. I did some calculations, and the calculation that I did was the saw that I was using, which was an MS311, has a maximum RPM of 13,000 RPM. And it has a 7 slot sprocket on it. So the speed or meters that it travels per second at 13,000 RPM is about 28.4. We multiply that by, and that's a second. So it's traveling very fast, 28.4 meters a second. That's very fast. But under load, it's going to be nowhere near that. It may even be half of that. But if we multiply that by 60, that's a second. If we multiply that by a minute, we're going to end up with about 1.8 kilometers. So if we halve that approximately, we're going to end up with under a kilometre. So that means that the chain is travelling approximately 1 kilometre per minute. So that's actually quite a lot, a distance. But yeah, under load, it'll travel less. It may only travel 600 metres or 700 metres, something like that. It gives you a bit of an idea that it's still a long distance. On a normal brand new chain, your depth is 0.65 of a millimetre, whether you use a constant gauge like this or whether you use the progressive gauge. But as we start to file the tooth down, the moment we start to file past about 3 millimetres of tooth, the progressive depth gauge comes in. Now, even we use the feeler gauges, and I done a check, and I found out that even on the tooth that I had, which was half worn down, and we put the feeler gauges under there, we had a gap of 1.1 millimeters. That's far much greater than the standard 0.65 depth. Now, due to the rocking motion that's caused, all chainsaws and all teeth have this rocking motion. They rock up and down and they take little bites of timber out. And then someone was sort of saying to me, and we were sort of talking about, well, you know, if you've got 1.5 millimeters, does it actually take a larger chip out on a progressive depth gauge? And I guess there's a bit of a debate there. Some people say it doesn't and other people say it does. So look, I'm not 100% sure whether it does take a larger chip. It would seem like that it may take slightly larger, but I can't say for sure whether it does. Someone sort of suggests that it doesn't, as the distance between, and you can see it actually on this chain here, the distance between the tooth, the point of the tooth, and the depth gauge on here is about 14 millimeters. It's actually quite a fairly large distance. And they're saying that as you increase this distance, you have to compensate for that. And the compensation is a larger depth on the depth gauge. So at this point here, which is the end of life of the chain, we're saying that we've got a depth of not 0.65 millimeter, we've got a depth of 1.5 millimeters. If we were using the constant depth gauge, you would find this chain would not cut very good at all. It would cut, but it's probably liable to be somewhere in between chips and sawdust. So what I would say is, out of all the trouble and effort that I went to, which it took 20 minutes using this digital angle gauge, it took 20 minutes to set all depth gauges at the right angle, roughly about an average of about 6.3 degrees. Was it worth all that effort? Well, I really don't think so. 20 minutes is a long time to spend setting the angles, the attack angle. For what benefit? The only benefit that I could honestly say, and I don't want to be biased here because I did it all, and then I don't say, oh yeah, it's better. Main benefit that I noticed was it was smoother, probably because the left and the right was balanced. That rocking motion wasn't violent, even though it moves up and down. If you've got it too violent, then you don't cut smooth, meaning that your depth gauges are far too deep. So it's interesting when you look at metrology, and then and you look at all the different angles and all the different ways that you can sort of do things with the geometry of chainsaw chain. And it hasn't changed that much since the last 10 or 15 years. It's stayed pretty much the same because there's not much you can do. It's all been researched and thrashed out many years ago. So the only thing that we can sort of play with is our top plate angle, our top plate cutting angle. That's the angle that either the grinder comes in or where we set our file. And we can change the depth gauges. Apart from that, that's about all you can do. But if you don't do it properly, then don't expect your chainsaw to cut. So the only thing that I would say in the end, that when we talk about the attack angle, the attack angle is that as this tooth hits the timber in relation to this angle from the point of the depth gauge to the point here, this is the attack angle. So the moment that the timber strikes this will kick up until it hits the depth gauge, and that's it. It can't take any more out there. So what they're saying, that as we file this back and the tooth is here, this large gap changes, and we really need a much greater depth to achieve the same result. That's the information I'm getting off people. So just because I've got a larger depth gauge at the end of the life doesn't mean that it's going to cut better. I'm going to take deeper chips out. What can take deeper chips out, that if I go beyond that point, so if I was to put the progressive depth gauge on and I was to file on the soft setting, then I took that off and I kept on filing, then put that back so that it sat below here, yeah, in other words, I'm guessing, then that would be very aggressive. Now, if you had a very powerful saw, like an example is if you had a 20-inch bar on an MS660, you could possibly get away with that. And maybe some people do. The only thing you've got to remember, the more and more aggressive that you make a saw, and you can make them aggressive, look at the guys that do the racing, but they're professionals. If you do make it a little bit more aggressive than standard, you need a little bit more horsepower in your chainsaw. So there's no good having a little tiny chainsaw of about 40 or 50 cc's and think that it's going to do wonders, change the bar, it's not going to work. You need something around, an MS 660, something like that, has got a lot of power. So you can play around with some angles and change your depths a little bit, but you've got to know what you're doing. There's nothing worse than filing down your depth gauges and putting that onto a cross-cut, cutting logs, and the thing's jumping around. Dangerous situation, kickback's worse. So you've got to know what you're doing. Now, all as I'm telling you, even from a safety point of view, that I'm using this depth gauge here from Stihl on the soft setting because the timber I'm cutting is soft. It hasn't been sitting out there for years. And when I'm putting this depth gauge on, there might be the odd tooth here and there that needs just a little bit of filing to get this a fraction of a degree, maybe a half a degree, maybe even 1 degree at the most. We're not talking much. Very, very little. So, but to me, it's really not worth going to all that trouble. To spend 20 minutes to gain what I gained yesterday, sawing, to me wasn't really worth it. So I would say to people out there that are thinking of using one of these gauges, they're good to check. Maybe just a little touch up here and there, and that's about all they're good for. But I certainly wouldn't be using this in my daily routine of sharpening chains. Anyway, thanks for watching. I hope you enjoyed that little video. Bye for now.